This video is on solving systems using matrices. A system of equations can be solved by using matrices. First, we want to rewrite the system as a matrix equation. So this system of equations becomes this matrix equation. Notice that I took the elements that are to the left of the equal sign and put those in a 2-row, 1-column matrix. And then I took the two elements that are to the right of the equal sign and put those in again, a 2-by-1 matrix, which can also be written as this matrix equation. Basically what we did was we undid the multiplication that was going on. Notice that if I were to multiply this matrix times this matrix, I'd go across this row and down this column, 1 times x plus 2 times y, which gives me this element here. And then if I were to multiply the second row times this column, 3 times x plus negative 6 times y, I would get this element here. So we're basically just showing how these two matrices were multiplied. So we want to rewrite it as the coefficients, the variables, and then the constants that it equals. This first matrix is referred to as the coefficient matrix. Often we use the letter A to refer to that. The second matrix is the variable matrix that contains the x and the y, and often we refer to that as uppercase X. And the third matrix, which is this 2-by-1 matrix, is called the constant matrix, also referred to as B. Written as a matrix equation, this would be matrix A times matrix X is equal to matrix B. Or in other words, A times x is equal to b. So to solve this equation, we want to isolate the variable matrix x, but we can't divide matrices, so we're going to multiply both sides of this matrix equation by the inverse of the coefficient matrix A, or A to the inverse. Recall that what looks like a -1 exponent really means the inverse of something, because matrix A times the inverse of A is equal to 1. So that's going to basically cancel out that coefficient matrix A. It's very similar to saying A times 1 over A is equal to 1. Something times its reciprocal, something, in this case a matrix times its inverse, is equal to 1. So A times the inverse of A times x is equal to, because this basically becomes a 1, is equal to the inverse of A. Oh, I'm sorry. No, sorry, this whole equation here. Yeah, this basically here becomes a 1. Yeah, and so then we have x times is equal to the inverse of A times B. Just a side note, the inverse of a 2-by-2 matrix is equal to this expression here. This is 1 over the determinant of the 2-by-2 matrix times this matrix here, which, as you can see, kind of rearranges the elements and makes some of them negative. That's not too difficult to calculate, but calculating the inverse of a 3-by-3 matrix is much more complicated, so we're going to be using a calculator to do some of this. So let's take a look at a couple examples here. Let's start with a system of two equations. So the first thing I want to do is rewrite my coefficient matrix, 4, -2, 6, and 9. And I just pulled the coefficients off of x and y. And that's going to be multiplied by my variable matrix, and my variables are x and y. And that's going to be equal to my constant matrix, which are the numbers to the right of the equal sign, so 22 and -3. So this is matrix A times matrix X is equal to matrix B. And recall that what I want is, I want to know what's the value of matrix X here. What is the value of little x and little y? And that's going to be the inverse of matrix A times matrix B. Now, to find the inverse of A, I'm actually going to do the rest of this on my calculator. So let's go ahead and pull up the HP Prime calculator, and let's put these numbers into here. So you'll notice that Shift 4 gives me access to matrices, and they name them a little differently in this calculator. They name them M, M1, and M2 instead of A and B. So in M1, I'm going to put the elements of my coefficient matrix, which were 4, and I need to hit OK, -2, and I don't need that third column, 6 and 9. So there's my coefficient matrix, and I will go back. I think I can go directly back to here, and I'm going to put into M2, I'm going to put in my my constant matrix, and that was a 2-row and 1 column of 22 and -3. Oops, I put that in the wrong spot. Shoot. Can I? There we go. I want -3 right there. Okay, so there's my constant matrix. So let's go back to the home page, and now what I want to say is I want the inverse of my first matrix times my second matrix. In this case, my first matrix was M1, and I can actually just do alpha and this right here to give me M1. So that's naming the first matrix that I put in, and I want the inverse of that, so I'm just going to add a -1 exponent, okay, times, and then I want matrix 2, so I'll do alpha M matrix 2, multiplying the two of those, hit enter, and my solution is the 2 by 1 matrix for -3. So x is equal to 4, -3, or solving the system of equations, writing it as a solution to a system, is the ordered pair 4, -3. So it's a little clunky using the calculator. It'll just take a little bit of practice to get used to that, but it's for a system of 2 equations, it's probably not too difficult. However, it's really cool to use for a system of 3 equations. So let's take a look at this. So let's go ahead and write our coefficient matrix. -5, 1, -4, 2, 4, 3, and 6, -3, -2. And that's being multiplied by our variable matrix, which in this case is x, y, and z, and that is equal to our constant matrix, 60, -12, -52. So this is my first, that's matrix A, that's matrix X, that's matrix B, or actually maybe we could even use some of the notation from the HP prime, because what I'm going to do is I'm going to put my coefficient matrix into M1, I'm going to put my constant matrix into M2, and then I'm going to do the inverse of M1 times M2. So let's go back to our calculator here, and I think I can just overwrite the elements here. So in M1, this is going to be my coefficient matrix. I can do -5, 1, oops, I actually want this one over here, -4, and then 2, 4, 3, and 6, -3, -2. And there's my coefficient matrix. Let's go back to matrix and let's put in the constant matrix, which was 60. Good, it's going down, -12 and -52. And there in M2 I have my constant matrix. Let's go back to the home screen, and I'm going to do M1. Unfortunately, it looks like it's being raised to the -1 power, but that's really the inverse, times M2, and hit enter, and that gives me the 3 by 1 matrix, -8, 4, -4. Go back over here, -8, 4, and -4. Oops. And the solution written as an ordered triple is -8, 4, -4. So x is equal to -8, y is 4, and z is -4. So in this video we took a look at how to solve systems of equations using a matrix equation, which is we found is very useful when you're doing a system of 3 equations with 3 variables, and also took a look at what that looks like and how you would enter that on the HP prime calculator. Seems a little difficult, seems a little clunky, but it's just with a little bit of practice I think you'll find it's a really cool way to solve a system of equations.